Okay, welcome to electrical machine lecture. Today we will discuss field test on DC series motor. So till date we have seen the load test which is applicable for DC series, compound and shunt motor, whereas Swinburne test, it is a no load test. It is applicable only for the constant flux machine, especially the DC machines. Uh, Next is the regenerative test. That regenerative test is applicable for the DC compound generator, DC compound machines. Now, field test is applicable for the DC series motor. This test is applicable for two similar DC motor. This DC series motor generally we use in the electric traction. So similar series motor is available in pair for especially in the traction purposes. So before going to see the procedure to conduct this test, first we will understand the circuit diagram. Here there are two series motors. This is one series motor and this is the second series motor, or we can say that this is series machine. These two are the DC series machine. One machine acting as a motor, whereas the second machine acting as a generator. The series motor whose armature winding and series windings is connected in series. So here this is the series of motor, this series winding, it is connected with the motor armature. Now the motor armature is connected in series with the field winding of DC series generator. So now this DC series generator acting as a separately excited DC generator whose field winding is excited from the motor current or the current drawn by motor. So this is somewhat different way. The machine are series, both machines are series machine. Only the excitation of the second machine is separately, therefore it acts as a separately DC generator. The generator output is vested in the external resistance R. By varying this resistance, it is possible to load the generator. As this generator is mechanically coupled, so that the load output of the generator will increase the input of generator. Now input of generator is nothing but the output of motor. So we can say that by increasing the output, it is possible to load the machine, to load the motor. Therefore, if you load the generator in such a way that the current drawn by motor I1 or the read by A1 indicates that the load on the motor. So this is the some description of the this is field test of the DC series motor. Now one machine runs normally as a motor and drives generator whose output is vested in the variable resistance R. Iron and frictional losses of two machines are made equal. So here the speed is same. The field current is drawn from the supply for the both machine, motor as well as generator. So it is possible to make equal iron frictional losses of the two machines. Now by joining the series field winding of the generator in the motor armature circuit so that both machines are equally excited. So here the excitation of both machines are equal since the field winding of motor and field winding of generator is connected a common supply voltage V. By running them at equal speed, definitely whatever the speed of the motor, the same speed of the generator. So here it is mechanically coupled. So now iron losses, frictional losses made equal for, for both the machine. Load resistance R is varied till the motor current reaches to the full load. It means that if you load the generator, ultimately it is loading the motor. And loading the motor means it draw more current. As soon as the current reaches to its rated value, which is read by the meter I1, it means that the motor is loaded to its rated load or at full load condition. After this adjustment for the full load current, different ammeter, voltmeter readings are noted down for the further calculation. So this is the some procedure for conducting field test on the DC series motor. Now we will see the procedure to calculate the efficiency of DC motor, which is tested by the field test. Now let RA is the armature resistance, armature resistance. RSE is the field resistance for both the machine. Okay, so here it is the RSE. RSE. This is armature resistance is RA. Same resistance RA over here. The series field resistance of the DC generator is RSE because it is the two similar machines are there. The current taken from the supply is say I1. The ammeter will measure the current I1. Current I1. Voltage V1, it is measured by the voltage which is connected across these two terminal, means across the DC series motor. This is series winding and this is armature. So itself, this part is a DC series motor. Whereas the current measured, current delivered by the DC generator is say I2 and voltage is V2, and supply voltage across this point, say it is voltage V. Already it is written. Okay, these are the current. So these are the current and this one. So we'll write I1 is the motor current. Motor current. Whereas V is the supply voltage. Or applied voltage. Instead of this one, it is okay, supply voltage. V1 is the voltage across motor. We are supplying the voltage across. V2 is the voltage of generator. I2 is the current of generator. So these are this one. Okay. Now the circuit is here. So it is, we will write the some equation. So power supplied or power drawn from supply to set, this is the motor generator set, is equal to V into I, because the here this is the voltage V and the current flowing through the set is I1, this much watt. So this is the total power supplied to the generator, to the motor generator set. Now, what is the output? This is the output. In this way, here it is the output. This is the output and this is the input. So I will write with red color. So it become easy to understand. So this is the power input. This is input over here, and this is the output. This is output. Okay, so this one is the power. Now power output or power output is equal to voltage V2, current I2, this much watt. So this is the power input, output, power output of set, entire set. Okay, so this is the total power input, total power output. For total losses, say WT is the total losses, which is equal to power input minus power output. As I said, so it is equal to V into I1 minus V2 I2 this much watt. It is a loss of power. Now armature and field CU loss. Say we will give the name as WCU is equal to the power loss in this series field winding, power loss in this series field winding, and power loss in the armature winding. So the current is same. This I1 is same through this RAC of the motor, armature current, and series field winding of the generator. So it is the current square multiplied by the resistance. So this is RAC, and only one RA. So it can be written as RA plus 2 into RSE is this one is the plus field loss plus armature loss is equal to plus armature loss in the generator is equal plus current flowing through, it is I2 square RA. So this is RA. So let's say this is the total copper loss. So now stray losses. Stray loss for the set is equal to power drawn is equal to, sorry, this is the total loss. Here it is a total loss minus copper loss. So if you know the entire losses, because the difference of these two is nothing but the entire losses. If you are subtracting copper losses from the total loss, the remaining loss is the stray loss. So which is equal to WT is the total loss minus WCU is the copper loss. So this is the stray losses. Now stray loss per machine is equal to WT minus WCU copper loss divided by 2. So let it is equal to WS stray loss. Already we have given the name, same nomenclature over here. So WS is the stray loss. Now, once the stray loss is available, it is possible to calculate the efficiency of motor. Efficiency of motor. So the first machine we are going to calculate the efficiency. Now motor input. Motor input. What is the input of motor here? Look at to the figure. So this is series field winding. This is armature winding. So this is series motor. So motor draws current I1, whereas the voltage across motor is V1. This voltage V is across the series motor as well as the series field winding. But the voltage across motor is only V1. So motor input is V1 into I1. V1 into I1, this much watt. Now motor losses. Motor losses is equal to armature CU loss plus field CU loss plus stray loss. Stray loss. So it is equal to armature current. Current flowing through the armature is I1 sphere RA plus series field current. The current is same, only the resistance RSE plus WS. So which is equal to I1 square RA plus RSE plus WS. Say this is the total losses. Now we will give the name as WM is the motor loss, total motor loss. Therefore, efficiency of motor is equal to motor input, sorry, motor output. So motor output is nothing but motor input minus motor input minus motor losses divided by motor input into 100. So here the motor efficiency is equal to motor input V into I1, V1 I1 minus WM is the losses divided by V1 I1 into 100. So these are the, this is the say motor efficiency by series test. Okay, so now it is possible to calculate generator efficiency. Efficiency of generator. Now look at this diagram. It is quite clear. The DC series motor is working in the normal condition. Only the series field winding is connected, but it is separate. It is separately excited for the DC generator. Whereas the DC machine, the second DC machine acting as a separately excited generator. So it is not in the normal position as compared to the DC series motor. So the efficiency calculated for the DC generator will not be a correct, but it is possible to calculate the uh, up to some extent we can calculate the efficiency of generator. So here generator output is equal to V2 I2, current into the armature current of the generator, voltage across generator. Whereas losses, total losses is equal to armature CU loss, armature CU loss plus field loss plus stray loss. So armature CU loss, the current flowing through the armature is I2 square RA. Current in the field winding, it is I1 square RSE plus stray losses is WS. Let the total losses we represent as WG. So this losses is available, generator output is available. Now efficiency of generator is equal to generator output. So it is V2, I2 is the output of generator divided by input of generator. So output plus losses is nothing but the input. So V2, I2 plus WG into 100 is the efficiency of generator. So this is the method to determine the efficiency of DC machine at desired load condition. Again, this is the advantage is that the DC series motor can be tested to its full load condition. So once the machine is full load condition, it is possible to examine the temperature rise, commutation, vibrations, sounds, bearing conditions, all these things. But the drawback is that it required the two similar DC machine. First, second, the power is wasted in the external resistance and ultimately it is converted into the heat. So the power is not utilized somewhere as compared to the back-to-back test or the Hopkinson test. The output of generator is again connected to the motor and partial power is drawn from the supply. So the test become economical since it does not require the full load current and full load power from this one from the supply means. So this is the drawback and advantages of the field test. So next time we will continue with this topic with some example. Thank you.